Hello, students. Okay. Yesterday I was talking to Mayank. So Mayank said that because next week there is a UT1 and most of the students want revision lectures. So we are going to have three revision lectures in this week. Okay. So I think it is fine. You can reply me on the chat. So we are going to cover major topics or major questions which will help you for preparation of UT1 revision lectures. Okay, so today though I have decided for taking revision lectures. Remaining two lectures, if you want the revision lectures for the remaining topics which are helpful for preparation of UT1, then you reply me on the chat, yes and no, your answer, so that I also come to know. But as per yesterday's conversation, I have sent you the message that you see the lectures 4, 5, 6, 7, 8 for today's lecture. So we will have the revision of Hadoop, HDFS, MapReduce framework and word count problem. Okay, let me tell you about the syllabus for UT1. As per your syllabus, university से जो syllabus आया है ना, that's in that syllabus the first three chapters are over from our syllabus. The first chapter is on big data. Okay, so it is what the topics that are covered in big data. First chapter are, Miss, I'm just telling you the syllabus of UT1. The topics that are there in the first chapter are what is big data, what is the importance of big data, why big data, then what are the types, what are the characteristics, 5 V's, that is volume, velocity, veracity, and value. What are the characteristics? What are the types? What is the difference between a big data analytics and the traditional analytics? And then what are the case studies and how people have benefited about the big data? That is the first chapter of your syllabus. Okay, so this is your textbook of Wiley publication by Radha Shankar Mani, and so if possible, you buy the book because everything is there in this book, or entire syllabus is there in the book. Plus, I'm preparing the slides. You can refer the slides also. Okay, or internet pe to it's a khajana of information. So you can refer the internet. Plus, my videos are also there. Okay, so the first chapter or one question will be there in the UT1 for the topic big data. The questions are what is big data, what are the types, what are the characteristics, volume, velocity, veracity, value, okay, that characteristics, what is the importance of big data, why big data, and what are the case studies and how people have benefited from big data. That is the first chapter of your syllabus. Now, the second chapter is the big chapter. Right? It's the main chapter of the entire syllabus, which is very, very important chapter because everything, all the tools are based on Hadoop. So the second chapter is on Hadoop. Hadoop is the base of this architecture, base of the big data systems or big data applications. On the top of Hadoop, everything is there. Suppose you are using PySpark. PySpark at the base is going to use Hadoop ka all the components. And there are four main components of Hadoop. There are four main components of Hadoop. That is common libraries, applications or common library functions like kernel that are needed to be loaded into the memory and they are running when you start running Hadoop. Okay, so the common library function is the first core component of Hadoop. The second component is the HDFS, that is Hadoop Distributed File System. Everything is a distributed system. This is a distributed system. So your entire file is divided into chunks, or everything is divided into chunks and is stored in a distributed fashion all over the entire cluster. So the second component of Hadoop is the HDFS, that is Hadoop Distributed File System. Third component is the programming API or software framework for Hadoop systems. That is MapReduce. So mapping and reducing kind of algorithms are there. And the fourth component is yarn. Okay. So what I'm telling you is that the second chapter is on Hadoop. Second and fourth chapter in the book. In the book, the second and fourth chapter. But in the syllabus, the second chapter. Okay. From the book, second and fourth. In the book, the third chapter is NoSQL. And in the syllabus also, the third chapter is NoSQL. Okay, so like this, I'm just telling you that there are three main topics in the UT1. Big data is the first chapter of your syllabus. Hadoop is the second chapter of the syllabus, and the third chapter is NoSQL databases. Okay, so I'm going to take the revision. You reply me on chat about your feelings like what you want, whether revision lectures or should I start with the next chapter of clustering algorithms for big data. I'm okay with anything. If you find it beneficial, then we will have the revision lectures. No one is replying me. I told you that I you need to be there. Okay. During this revision lectures, I'm taking it again. So I want all of you be present during the lecture for revisions and reply me. Okay. And in one of the lectures, I will even have a quiz of us, like basic things, just one answers, and that you will be enjoying to solve the quiz during the lectures if you are attentive for the 1 hour of the lecture. So in one of the lectures, we will have the quiz also. Okay, so I'm just creating. So many students are saying yes. So I'm just creating a background so that once the background is ready, you view the videos, and if you are viewing the videos, you will be able to solve the answers in the question in the exam. Okay. So the second chapter is Hadoop. Hadoop is very important chapter, and the third chapter is NoSQL. Okay, so today I'm concentrating on Hadoop. Now Hadoop में क्या सीखना है? Hadoop में there are core components. The four core components are there, and there are some advanced components. Okay, so today I'm going to teach you about Hadoop because big data is very simple. अच्छा है वो simple है वो. It's easy to understand, and you see the videos, you will be able to understand it and see the notes also. Okay, if time permits, in these three lectures, I'll take the revision of big data also. But today I'm starting. Today's learning objective is about understanding of Hadoop, HDFS, MapReduce, how the workflow of HDFS and MapReduce. Okay, and what is Hadoop mean by? So these are the questions which are asked in the exam. I'll just present it. Just a minute. In the exam, they ask on Hadoop about the high-level architecture of Hadoop, or HDFS in detail, or MapReduce in detail, or word count problem, or matrix multiplication problem of MapReduce, or goals and assumptions of HDFS or Hadoop, and how Hadoop is very important. What are the limitations of Hadoop? What are the advantages of Hadoop? And how it solves the big data problems. Such kind of questions are there in the exam. Okay. So I'll just revise it again. What are the questions of Hadoop? Hadoop ka core components, Hadoop ka ecosystem components, HDFS in detail, MapReduce in detail, word count ka workflow, then matrix multiplication algorithm, matrix vector multiplication algorithm, some and okay, these are the main things. And Hadoop ka limitations, Hadoop ka goals, how Hadoop big data problems are solved by Hadoop system. This is also a famous favorite question of exam in paper setters. Okay, how big data problems are solved by Hadoop system. This is also a favorite question of examiners. Okay, so we will see this. So as we know that big data is a huge data, it can be structured, unstructured, semi-structured data, and it is a relative term. If someone cannot handle the data, then it is a big data for that organization. Like suppose some petabytes of data is a small data for one organization, but it can be a big data for the another organization. So we say that whenever our infrastructure or our computer systems or our software is not able to handle the huge amount of data, then it is a big data for us. Okay, so it is a relative term, and it is going to grow exponentially because of social media network sites getting popular, and people are contributing. People are continuously on internet. They are creating their footprints. Each and every click of the user who when he is on internet is recorded, so it's generating a huge data. IoT is generating a huge data. So this is about big data. Big data is getting increased day by day. So we have to have systems which will handle this big data. Even if the size is getting increased, we need to have a scalable systems which will support this big data. And it is not possible to store this big data on a single machine because कितना भी capacity बढ़ा दो CPU का, if you will use GPU, but that GPU will also have a limitation to access the memory. Even memory भी capacity बढ़ा दिया, and so much of memory can be stored on a machine, but the CPU का limitation है, it can access only some amount of memory at a time, and the chip is getting heated, so we cannot scale up systems. This is called as scaling up. If you increase the capacity of the CPU and memory and hard disk, then you say that you are using a powerful computer, and then you are scaling up the system. But scaling up doesn't work beyond some amount of time. So we need to have a scale out kind of architecture. In scale out kind of architecture, we don't increase the capacity of the existing machine, but we will add a new machine. So we have today five computers handling the data today. Tomorrow we may add five extra computers. So you can scale out the system. So scalability is required. And for Hadoop kind of systems, we use the scale out architecture. Okay. Why this big data is important? Because we want to reduce the cost and time for production, and we want to identify the need of the market, and we want to provide the offers to the customer, so attract the customers, take the smart decisions. And even if we want to improve the business by understanding the failures, issues, and we want to detect them, we want to generate the coupons, and risk also we want to calculate, or some frauds we want to detect. So like this, we want to do some predictions, we want to do the recommendations, or we want to do the clustering operations, we want to find out similar items on the big data. And the data is a huge amount of data, so we are not storing the data at one place, we are distributing the data on multiple computers. So the Hadoop was the first architecture which was invented. Nowadays, so many other things are on new architectures are also available. Like there is one side Databricks. In the Databricks also you can explore for doing your mini project, and you can, it is a cloud and where you can perform your distributed applications in a database. So people have now invented new architectures, but Hadoop is the base of all the architectures. And so once you understand Hadoop, your base is created in the college level, and now whenever you go out, you will be able to understand and work with any kind of architecture. So that's why Hadoop is there in the syllabus, and it is outdated. People say, industry people say that it is outdated, but it is important to understand Hadoop. Once you understand the Hadoop, you will be able to work with any other systems. Okay, so Hadoop is there in the syllabus because we cannot jump to the other architectures directly. We need to know the basics behind it. So Hadoop is an open source. So here it is very important thing that it is open source, because this big data analytics was done previously by the organizations such as Google, Facebook. They were doing since long time. Amazon, they were doing since long time. We were not aware of doing this such kind of big data analytics. But because they had their own infrastructure and their own softwares, and the small organizations or a startup was not able to do such kind of analytics. But with the availability of the products such as Hadoop, which is open source, now it is possible that anyone can do such kind of analytics. So it is becoming famous, and it is a Java. So Hadoop is open source. So it is easily available. Java based framework. So portability is also there. And it is developed by using Java. And what it does, it allows you to store your big data in a distributed environment. Your environment is a distributed, multiple computers connected to each other, and you are dividing your data in the small chunks, and you are storing the data in a distributed fashion. So Hadoop allows you to store. It performs majorly two operations: storage and processing. So it allows you to store your data in a distributed fashion across cluster of computers, and it allows you to process it in a distributed computing environment. So distributed storage and distributed processing both are allowed, and both are is easy to do it. So that is the main feature of Hadoop. And Apache is the organization who has taken over this project of Hadoop, and they are taking care of it. And it is open source, people can contribute it, and it is growing. Okay, so people are continuously working, they are very happy, and they are creating the small modules like new other open source add-on components of Hadoop, and it's getting expanded. Okay, so this is about the introduction of Hadoop. How it got invented? It was invented by these two scientists, Cutting and Caparella. They were working in Yahoo, and they were working on the working on a search engine, and the name of the search engine was Nudge search engine. Okay, the search engine has two major components, crawler part and distributed processing part. Okay, every search engine has at least two major components, crawler part. Crawling में क्या होता है? It will crawl the entire internet, and it will after crawling, like spider is also called as a crawler. Spider is another name of the crawler. Crawler will crawl the entire internet, will take all these HTML files, and then it is doing and it has to store. So what it has to do after crawling, it has to store such a huge amount of data, and it has to do some processing like indexing operations on that, and it has to do some processing on this huge amount of data, so that whenever any keyword is entered by the user, it can quickly send the required results. So what are the two components of any search engine? Crawling, and then after crawling, whatever the pages you are getting, they are to be stored in a distributed fashion, and they are to be processed. So distributed storage and processing was the another component. So these two scientists, they were working on their own search engine, and for the crawler part they gave the name as Nudge, but they afterwards in 2006 they joined Yahoo, and they started working with Yahoo, and Yahoo got famous and got developed properly. That search engine was actually, before Google, people used to use Yahoo search engine. I have also used Yahoo search engine for some days. And the second portion of Yahoo was storage and distributed processing part. So this is search engine ka second component is a storage and distributed processing, that is named as a Hadoop. So they worked on two components, Nudge component, which is crawler, and the Hadoop component. Hadoop component is a component that performs the storage and distributed processing. Okay, and it is named after this scientist Doug's name toy, and this was the toy, and this is the logo for the Hadoop. Okay, so this is so we can say that Hadoop is the framework that allows us to store and process in a distributed fashion across the cluster of computers. And whenever any such kind of distributed system is there, you need to remember that any distributed system, it should be scalable, it should be fault tolerant, it should handle the failures, and it should provide the failure transparency. It should be economical. Otherwise, it will not work. There are so many, like 10, 15 main major components are there. But with respect to this, we can remember at least this four, that it should be scalable. You should be able to go on adding the machines, and your system should be available 24 by 7. Even if there is any failure, it should be handled in the background. User should not be able to come to know about any failure, because in your cluster, if you are having millions of computers, then there can be thousands failure in a day. After three, like I have told you in one of the lectures, that whenever you buy a machine, that machine works well approximately for 3 years without any fail. But after 3 years, there may be any hardware failure on an average. Okay, it is not compulsory, but on an average. So if millions of computers are there in the cluster, then there may be thousands failure in a day, and 1,000 failures in a day is a big number. And then your system will be down for so much of time. So the system should be designed. Any distributed system should be designed in such a way that even if there is a failure, the end user should not be able to understand that there is a failure, and the work of that machine should be taken over by the other machine, and the in the background it should handle the failure. And some people, the team will is required, then they will again add a new machine, or they will replace, or they will do something, but the system should be running in the foreground. Okay, and it is economical. It should be economical, means that the system, the startups or small organizations should be able to work with such kind of systems. If you are using hi-fi machines, and then you cannot afford, and then you will not do, or you will not go for that, because it is not easy to work on such systems. So it is Hadoop is based on, these are the goals when Hadoop got invented. So when they invented Hadoop, they thought this is four main, at least four main things in their mind. And so they use the commodity hardware. Commodity hardware is a term that is always used in big data analytics ka terminology. Commodity hardware means a simple machine. Let's say 50,000 may on an average we get a one PC. So such kind of a simple machine which is having a CPU, and memory and hard disk, and we don't need a monitor and keyboard because all the systems are supposed to be processing and storing something, and we will have the client machine where you will have a keyboard and interface to interact with all such connected machines. So we need only a computer with CPU, memory, and hard disk. And it is a simple machine with the Linux operating system. So Linux is also open source, and we don't have to spend money on that. Okay. So Hadoop does the massive data processing and fast processing. Even these are some of the components. Whenever any Hadoop related question is there, you need to remember all these points, that your data, it should be able to store such a big data. These are the assumptions. Hardware may fail, so handle that. Portability is needed. And then whenever you store a file in a distributed fashion, the file is stored and file can be accessed with core Hadoop systems in a sequential manner. Okay, in a sequential manner. So batch processing is used, and but even if it is a batch processing, overall time to get the answer is high. There is low latency. To perform a small task, it may take much time, but for performing overall analysis, you will save the time and you will get the answers very fast. Okay, and you can remember that whenever the file is stored, it is accessed in a sequential manner in HDFS. But we also remember that such kind of applications, where we need to write the data only once, and we may have to read the data again and again. And what we do is that we move the computation to the data. Okay, this is also I told you for many times that whenever we perform any program or when you execute a program, your program and data both reside in the memory, and your instructions are executing, or that program is running on the data which is residing in the memory. Even if it is a database kind of application, your data, when you fire the query, your data is brought from the web database server into your data structure of your application. In your program, you may have an array of objects, and you fire a query and you get the results in the object which is residing in the array of your machine, your program. So what you do in the normal computation, normal programming, is that you bring the data from database server to the location where the program is running, and then the program and memory data are there in the same memory locations, and then the program is executed. But here it is a huge data, so it is not possible to bring the data to the location where the program is there. So we write the programs in a different style, and we create multiple copies of the program. Or and data is, because data is stored in a distributed fashion. So the program is traveled through the network, and program ka size kilobytes mein hota hai. Kilobytes or maximum a megabyte. So the program is very small. So you write a program, keep it at one place, and then the program is sent to the locations where the data is residing. And then the program is running on the data, and then the results are stored also in a distributed fashion. Okay, your input is in the distributed fashion. Your data, your program will go to the place where the data is residing, and then the results are also stored in that machine only where the data input is there, or the results are combined together and they are placed at one particular place. Okay, so we work in this manner. So these are also the assumptions, and it supports tens of millions of files in a single instance of Hadoop. Hadoop can support tens of millions of files in a single instance of Hadoop. Okay, so this was the background of Hadoop. These are the four core components. Sometimes the dedicated question is there for the four components. And the components are Hadoop Common Library, Yarn, that is yet another resource negotiator, that is a resource management of the cluster. HDFS is a distributed file system, and MapReduce is a Yarn-based system for parallel processing. Okay, I'll just repeat this again. These are the core components. If the question is there, you explain the core component, then you will have to explain HDFS and MapReduce in short. But there can be a question, dedicated question on HDFS, where you can just create some background about this topic and then you explain HDFS in detail. Or there can be a dedicated question to explain about a MapReduce, and then you will have to just create the background and explain MapReduce in detail. Or if the question is there to explain the core component, then all four components in short. But everywhere you draw the diagrams, and make it presentable, because in the final year your papers are corrected by the external who is not from our college, or it will go to the university, someone will correct the paper. So you're present in the final year. Always it is important to present your information in a very good manner in the exam, with the diagram, labeling, and then writing. And okay, so do that so that the examiner will give you the full marks. So common means common library. So okay, so you know now the core components are common, yarn, HDFS, and MapReduce. So common means the common library functions such as jar files or kernel kind of or startup scripts, and the JRE, because it is Java based framework, and some libraries and utilities which are needed, minimum things which are needed to start the cluster or Hadoop. Okay, then the second component is HDFS. So this is the diagram that you have to draw in the exam for HDFS. In this diagram, just see the main components. The client application is there. Here there is a client. Client can communicate with the name node. In the HDFS, HDFS is responsible for storing your data in a distributed fashion. You have a big file, and the file is stored at multiple computers. For simplicity, I'm just showing you here 5 computers, but there are millions of machines. So the name node is here there is a name node, there are data nodes, these are the data nodes, and all these data nodes are connected in a single rack. So this is one rack, and inside one rack maybe some computers are there, 16 computers are there, they are connected to each other, and they are in one rack. So like this there are multiple racks in the entire cluster, and in the second rack I'm just showing here 2 machines, and these 2 machines are connected to each other. Now again these 2 racks are also connected with each other by using a switch. So like this all the racks are connected to each other, and that is the entire cluster of the system. So there is an so what are the major components of HDFS? Client, name node, and data node. And data nodes are located inside a rack. Okay. Client can communicate with the name node. Name node stores the metadata information, and the actual data is stored at the data nodes. Okay. So as in this diagram, you can just remember this diagram with 3 components: client, name node, and data node. Okay. And here it is a master slave architecture. This HDFS is a master slave architecture. Name node is the master of the cluster, entire cluster. He is the master, and all other data nodes are slaves. So master gives all the instructions to the slave nodes, and slave node work as per the instructions given by the name node. So name node is master, and data nodes are slave. Now, what is the job of name node? Mainly at high level, you can say that it keeps the metadata information, like what we want to do with this name node and data node of HDFS. It is a distributed file system. It is a file system similar to अपना DOS file system or Unix operating system का file system. But file is divided into chunks, and these are the blocks. ये जो squares है, these are the chunks which are stored. So your file is it's so big that you cannot store it on one machine. So you are storing some portion of your file here, then here, then here, like this on the cluster. And then we need to know, like, I mean, we want to access the file. So to access the file, we need something like inode or the directory kind of structure. So here it uses file system, hierarchical file organization, traditional, and so this name node is responsible to keep all this metadata information about the file, and we can perform the operation of opening a file, creating a file, moving a file from one location to another, remove the file, rename the file, close the file. So with respect to file, whatever the operations are to be performed are facilitated with the help of name node, and client will talk to the name node with this request that I want to create a file, I want to rename the file, I want to search, I want to get the file. But actual read and write operation will happen with the data node, because actual file is there onto the data node. So the client can tell the name node that he want to open, he want to rename, or he want to move the file, or he want to close the file, or he want to delete the file. Okay, so all such metadata information about the entire file, which block is residing on which location, everything is maintained by the name node. Then the name node is So the data nodes are the slave nodes. They are actually responsible for creation of this block. Okay, so this data is in the form of a block, and it is responsible for creating this data, or iska deletion, or iska replication. So it will get the request from the client that he want to read this particular block. So that operation will be done by the data node. So read and write operations of data nodes is done by data node. Okay, so I think you have understood some functions of name node and data node. That name node is master, data node is slave. Data nodes are actually storing the data. So client can perform read and write operation of the data block by communicating with the data node. But for the entire file, client communicates with the name node that he wants to create, delete file, or rename the file. Such operations are facilitated by name node, and name node keeps all this metadata information of the entire cluster. Name node knows each and everything about the cluster, that which block is residing on which machine, and what is the name of the file, how many files are there, how much mm, how many data nodes are there, how many data nodes are alive. All this information, metadata information about the cluster is with master. Okay, so so now let's see. Let's take an example that how it works. Okay, so suppose I have a file. For simplicity, I'm taking so this is a Hadoop ka component HDFS. Okay, we are learning about the workflow of a particular file. Suppose I have a big file, and for simplicity, I'm just taking 3 blocks. In my file, the file is divided into 3 blocks, A, B, and C. So this is my file, and I am a client. And my client application, I write a client application, submit it to the cluster. What is the client application? That client talks to the name node that I want to store a file. Okay, so it can be a Java program which uses HDFS APIs, Hadoop APIs. So you can write a Java program, and you use the Hadoop APIs, and then you say that you want to store the file. Or you can have get a prompt after installation of Hadoop. You get a prompt like a dollar prompt, and then in front of the prompt you can use a HDFS command line prompt, just a dir command hai, and like that, or a ls command, or make directory command like this, or store create file command. So like this, you can write a HDFS command to store the file in front of the prompt. So it is a finally, even if it is a Java program, finally it is a HDFS request. So that request is submitted in the cluster name node. Now in the name node, in this entire cluster, this is a computer. On this computer, this process is running. What is meant by name node? This is a machine. On this machine, this name node is a process at the operating system level. So that name node process is in the running condition. Okay. So now this name node receives it, and it is responsible for storage. Okay. Then even on that same master machine, uh, if sometimes, like nowadays with the complex clusters, you may have some another machine here, and on that another machine the another process is running, that is the job tracker. Okay, so there is no guarantee depending on your cluster architecture. This job tracker is also a process running on the same machine, or it may be running on the separate machine, but it is not a part of HDFS. Job tracker is a part of MapReduce. Okay. So for HDFS, we will just ignore this job tracker for the time being. So what happens is that I have a big file, and file is divided into 3 chunks. Matlab, the name node will decide, and it will divide it into 3 chunks. And I'm just saying that I want to store this particular file on the cluster. So name node is responsible for storage. Name node is also connected with the secondary name node, or a backup name node, where the backup of this entire machine is kept, and after every 1 hour the backup is taken, and it is a secondary name node. So if the name node is failed, secondary name node is there who will work for name node. Or so name node will go through this particular file. It will see that how much big file is, and then it may come to know that okay, I can make 3 different blocks of the file. ABC are the names of the blocks, and normally it is 64 MB or 120 for recent or advanced Hadoop systems. Now 128 MB size is there for the block, and it will create 3 different blocks. Okay, so it can be 64 or 128, and or even you can change in the configuration as the administrator, and it will say that okay, there are three blocks to be created. Now the system should be fault tolerant, so that so to achieve the fault tolerance, if the data node is failed, then what to do? So for that purpose, this particular data is by default stored with three different copies. Okay, in this diagram I'm showing B and C already replicated. Okay, I'm just showing you the sequence of operations. The same thing will happen for block C and B also. So what they do is that if the machine is failed, then the data will not be accessible to the system. So it should not happen. You should not data should not get lost. So the three copies, minimum three copies are maintained, and it depends on this factor. DFS dot replication is equal to 3, which is done in the HDFS site.xml file of the cluster configuration file, and three copies are then maintained. So how it does this copies is that in particular it will select two different data nodes from the same rack. So if this is a primary copy, this is, if C का ये primary copy है, so one copy is residing here and one copy is residing in the same rack, and this third copy will be residing in the another rack. Because if the rack is not accessible, if the switch is failed, then this entire rack is not accessible, then also the system should be available. So the third copy is in the different rack. Okay, so like this they do the replication, and for a block, three replicas are stored at a time. So what name node will know? Name node is a master. He knows everything about the cluster, so he will keep track and he will check that how many data nodes are there, how much memory is available, or which data node is overloaded, which data node is not overloaded. So by taking all this such kind of analysis, it will decide that A should be stored on data node 1, data node 2, and data node 5, and these are the IP addresses of these machines. So data node 1, data node 2, and data node 5 पे store A. Like this, it will give this information to the client that okay, your file is divided into three chunks, and one chunk A will be stored on these three machines, B will be stored on these three machines, and C should be stored on these three machines. And the first DN1 is primary for A, DN3 is the primary data node for B, matlab main data node for, actually anyone can access to DN1 if he wants to access block A. Block A is discoverable on data node 1, which is the primary, and these are the replicas. So such kind of information is submitted to the client, and then client will see. Now for block A, client will get the primary node, and it will establish the TCP/IP connection with the data node 1, and then it will store that data. It will send this block to this machine. Now this data node 1 will come to know that okay, other two replicas are it has to make the replicas, and they are to be stored on data node 2 and 5. So now this data node 1 will communicate to data node 2. Okay, this name node is not communicating with these data nodes, or client is not communicating with all the data nodes. Okay, what happens is that this data node 1 will communicate to the data node 2, because they want to reduce, or they want to disperse the traffic of signals between the machines. Otherwise, what will happen in the millions of machines? The client is interacting with all these machines, and so many signals will be going from client, and there will be a traffic jam. So what they have designed in such a way that the signals will be transferred between multiple computers simultaneously. So they are not trying, they're trying to reduce the traffic, overall traffic. Okay, so that's why client will communicate with data node 1, A block will be stored, A will communicate with data node 2, and it will tell that the next copy should be on data node 5. So data node 2 will communicate to 5, will get establish the TCP connection with 5 and store the third copy. If the third copy is successfully done, then acknowledgement, and then from 2 to 1 acknowledgement, then data node 1 to client acknowledgement is sent. So client will come to know that the data block is stored as well as replicated properly. Client will also communicate with the client will communicate with the name node that successfully the block A is stored. Okay, like this, all the blocks are stored. Once all the blocks are stored properly, then the name node will finalize, or it will update its metadata information. It has the metadata information, so it will update the metadata information, and it will have up to date information about the cluster, about how the blocks are stored on which machine. Okay, so here now to handle the failures, this data nodes dotted line indicates that this data nodes, they keep sending the heartbeats to the name node. Heartbeats means it can be a hello packet signal. It can be a hello packet signal. So after every millisecond, within every milliseconds or few milliseconds, the data nodes are sending their heartbeats to name node, and name node come to know that these machines are alive. They are saying that I am alive, I am alive. By sending a hello packet. Even the name node sends the signal to the secondary node, name node. So if the secondary name node is not receiving the heartbeat signal from the name node, then secondary node will come to know that what has happened to the name node. It will try to get connected to the name node, and it will come to know about the failure. Okay. So even the name node, if it is not receiving any heartbeat from any data node, then also it will try to check whether this machine is failed or not. And if the machine is not able to send any signals, then it will hand over the job of this machine to the another machine automatically. So the user don't have to do anything. And here these heartbeats are sent. Okay, the frequency is in 3 seconds. Every 3 seconds they are sending the heartbeat. Uh, and after sending the 9 heartbeats, the 10th heartbeat will be the block information. Okay, on the 10th heartbeat, every data node sends the detailed information about all the blocks. But otherwise, 9 signals are the normal signals of hello packet. Even a secondary name node takes the backup of name node after every 1 hour of time. And this I'm going to take in detail in the next slide. But right now you can understand that this is about the job tracker on the same machine. But if the cluster is too big, then you may have some other machine, and job tracker process is running, which is a part of MapReduce. So HDFS का components क्या है? Client, name node, and data node, and this way the file is stored. This is everything about HDFS. Now this next component is about the MapReduce. MapReduce is responsible for parallel processing. HDFS is responsible for distributed storage, and MapReduce is responsible for parallel processing. MapReducer का component is job tracker and task tracker. So on this machine, there are two processes minimum: data node process and a task tracker process. And the task is the actual program or task that is written by this client to execute. Okay, and the job tracker is the entire job, like all the tasks together combined is called as a job. So job tracker keeps track of a job, and the task tracker, they keep doing small tasks. When all the tasks are done, then the job is done. Okay, so these are the components which are because I cannot ignore these components even if I'm drawing HDFS diagram. So I've kept these components. That job tracker is also there, which performs the parallel processing, and job tracker keeps track of all the tasks which are running on the data nodes. So here it is compulsory that this task tracker is there with this data node, this task tracker is there with this data node, but here it is not compulsory. You can have a dedicated machine if your cluster is complicated. And there the job tracker is in the running condition, and name node and job tracker also communicate with each other whenever there is a need. Okay, and the tasks are mapping task or reducing task. So that mapper, this different color mappers and reducers. This particular program is written by the client. So Hadoop's target is a cluster of 10,000 nodes, and like this you can have multiple clusters. Okay, for replication, for even for data integrity, checksum is calculated. Whenever the data block is copied from one place to another, some kind of checksum mechanism is used to ensure the data integrity. But data is not stored in an encrypted fashion. Data is stored as it is. So there is no, so it is not very safe to store your password information or credit card information because the data is not in the encrypted manner. But only what happens is that the user will have to do the authentication with the cluster with the name node. So only the authenticated user and authorized user can access this data. That is the security provided. Okay, and here I indicates here this I blocks they indicate the intermediate output. This mappers and reducers after executing they create the intermediate output, and then the reducer generates the actual output. So we'll see that in the MapReduce in detail. Okay, so I think HDFS you have understood. HDFS is for distributed file storage, and name node in coordination with all the data nodes. It is done. And so for HDFS, you need to explain about client application, name node, secondary name node, and data node, and this replication part. Okay, so I think it is very easy now to remember. Once you remember the diagram, it's very easy. But in the exam, when you write the answer, you need to write down all the features of HDFS. So with respect to this figure, you can even remember the features. So I have prepared this slide. All these slides are prepared by me. I have prepared the slides from scratch. Okay, so here you how to remember these features. So with respect to the diagram, you can remember the features. The first feature is this distributed file system. HDFS is a distributed file design. Okay. Second feature is that it provides a command line interface. Like here, the client communicates with the name node, so you get a dollar prompt. So that's why I'm writing it here that it provides a command line interface to the client to give the command to store the file, rename the file, delete the file like this. Then it also the next feature of HDFS is it runs on the commodity hardware. This is a commodity hardware, simple machine with the Linux operating system. Then the next feature is that it is highly fault tolerant. Fault tolerant means this secondary name node hai or signals hai, heartbeats hai, and the backup is taken. So it is highly fault tolerant. Then distributed file storage. File is stored in a distributed fashion and in a redundant way. So block A is for 3 times. So redundant storage is there, means replication is there, and this is also a feature. Then it allows the applications to perform parallel processing. Okay, so parallel processing is possible because of the distributed storage. Then file permissions and authentication, authenticated user and if file permission attributes are there, then only the client can access the file according to the file permission. Read, write, execute. Then highly scalable because you can go on adding the machines. Your system or cluster is in the operation. In the background, you can go on adding the machines and the system is not affected. Highly scalable, horizontally scalable, scale out operation, high throughput. Then streaming access to file data. That means your file is A is here, B is here, C is here. When you access, then there is a sequential access to the file. So that's why HDFS is a little slow. But on the top of HDFS, now we have another components which can allow you to have the random access to anything. Okay, so but HDFS by default provides you a sequential access to a file. So whatever I just now I told is written down here, and this is what you have to answer or write in the exam. Okay. Then this is with respect to name node. What are the functions of name node? That it is like maintains inode kind of information, file system namespace, authentication, authorization, renaming, closing, opening of file directories, checkpoints. These are the functions of name node. Then it also is responsible for monitoring the health of the data block. Okay, replicates the missing blocks. डेटा नोड का फंक्शंस है commodity nodes है Linux operating system है actual storage read write operation is allowed user can directly communicate with the data node to read a block to write a block heartbeat send करता है then it provides also the shell like file system HDFS provides the shell like file system so the goals of HDFS are that fault detection and recovery is done transparent fashion used data set can be stored and computation is performed at data. Okay, so this is done. Now we'll move on to the next component of Hadoop that is MapReduce. Okay, so I'll just show you the workflow of MapReduce. What is meant by a MapReduce? Okay, so what is the first component? Common library functions, Java ka startup function, startup libraries, and kernel kind of shell scripts. That is about the common component of Hadoop. First, second is HDFS, third is MapReduce, and fourth is Yarn. So now we are going to learn about third component, that is MapReduce. Okay. Now in the this is a diagram. Again, the diagram is same. Cluster का structure तो same ही रहेगा. So this is a diagram where name node is there, data nodes are there, and now I'm showing this task tracker little bold in the bold format. The task trackers है. Every data node task tracker is running. So task is performed at data node where the data is residing. Task means the program, and the program is written by the client or the programmer. Okay, so in this architecture now we see the job tracker. Here I'm showing job tracker as a separate machine or separate process on different computer. There is no guarantee, it can be anything. So here name node is responsible for storing metadata and a secondary name node. So these are the components of your Hadoop cluster: client application, name node, data node, job tracker, task tracker, secondary name node, and job history server. Okay, so name node, secondary name node, and data nodes are responsible for storage. Job tracker, job history server, and task tracker, they are responsible for parallel processing. Okay, now what are the steps? Client is going to write the program. So what client will write? Client will write main function. Then he will write a mapper function, and he will also write a reducer function. So he is going to write three different functions for performing any task or anything. जैसे matrix multiplication करना है, so he will write a main program, mapper, and reducer. Or if he has to perform word count, frequency of word in a particular file, then he will write mapper, reducer, and main. So always for all the applications of map reducer, client has to write three functions: main function, mapper function, reducer function. And this is the file. ABC is a file. So what happens is that client will do everything, all these things, and he suppose he is giving the name of the file as a word count job dot py file or word count job dot java file, and in that file all these three functions are there, and this is the name of the file, word count dot text file. So that will he will enter feedback dot text file. He will do that, create that files, and he will enter this into the cluster. He will submit it to the cluster that I want to execute this job, my file, matlab this program, wc job.py file, and my data input is a feedback.txt file. So now in the previous HDFS architecture, we have seen that feedback.txt file ka तीन blocks हो गया ABC, and the blocks are stored. So once you submit this, the name node is going to store all the blocks like HDFS architecture में जैसे सिखाया वैसे. So I'm assuming now here that the first task of storage is done already. Okay, so in this slide, A is stored for three times, B is residing for three times, C block is also residing for three times. Okay, and I'm showing this in the primary, like this is a primary in color. So this is a primary data node for A. मतलब A के लिए data node 1 is a primary node. B के लिए data node 3 and C के लिए data node 5. These are the primary data nodes for these three blocks. And now I'm assuming that the name node has stored it already. Okay. Now it has to execute the program. So the for that program, the job tracker will go through this program. It will identify who is the mapper function, who is the reducer function. It will extract both the functions, and that functions are available with the job tracker now. Okay, now the job tracker, and in the I've shown these heartbeats in the dotted lines. Okay, so here also there is a master slave architecture. Job tracker is the master, and task trackers are the slave. MapReduce is a programming framework that allows user to write the program by using APIs. So with the help of APIs, we write this mapper function and reducer function. But in terms of hardware, this job tracker is also a process, and the task tracker is a process. And this, as per this architecture, framework architecture, job tracker is a master and task trackers are the slaves. And so it receives this file, It will consult with the name node that I want to execute this file on this program on this file. So for this program, this is the data. Now the name node has already stored the data, because I told you that the storage can be done today and you can do the analysis on that storage tomorrow or after 1 year or after 5 years. So you keep on storing the data, and then after 5 years you can do the analysis on the stored data. So storage and processing, these are two different tasks. But when you have to do the processing or analysis, that time you need to specify your file name and the data file name. So data is already stored. Now the job tracker will tell name node that I want this particular file, I want the details of this file, I want to work on this file. So name node will see the metadata information, and it will come to know that okay, for block A you refer data node 1, for block B refer data node 3, and for block C refer data node 5. So after consultation, name node will provide this information to job tracker. Now job tracker know where the data is residing. So now it will do the calculation or its internal work, and it will identify and it will extract this mapper function, and uska three copies. One copy it will send to this task tracker, one copy on this another, and the third copy on this another. Matlab data node 1, 3 and 5 pe it will send the mapper function. So program is traveled and it is residing at this task tracker. So program is now there in that machine where the data is there. And the same copy, these are all three functions are same, exactly same code is there. There are no three different types of functions. There is only one function. Same function is running on the data. Okay, so it will send this program to this machine, and then it will ask the task tracker to complete the task. Now the task tracker will okay, even it will decide about the reducer depending on the cluster architecture, and it will decide that data node 2 and data node 4 are little bit free machines, and it will send this reduce function ka do copy. Okay, it may have one copy or it may have 10 copies, we don't know. Depending on the cluster, depending on the complexity of the program, this architecture will take name node will take a decision, and it will provide the suggestion to the job tracker. So as per that, it will send the reducer function on these two machines, the same copy. Okay. Now this mapper will start working on this A. Okay. So all three mappers will start working in parallel. Okay. So that's why I'm showing you here the three arrows. This mapper have started working on this A, this mapper on this B, and this pink mapper on this pink block C. Okay. So it is a parallel processing. In parallelly, all three blocks are processed, A, B, and C, and the same function is working on that. And after execution of this, because this is the input, this is your program, so output to generate hoga hi. Output will be stored in the form of a key value pair. Output always, in case of MapReduce programming, the output is stored in the form of a key value pair. So what is the key here? Like depending on this, suppose it may create some keys, and like key is k1 and the value of the key is 1. Key is k1, value is 1. Key is k2, value. So I'm just assuming. So it creates key values, and this is the intermediate output. This output is not a final output. It is an intermediate output. Here also it will create some of the keys and values, and here also it is creating some of the keys and values. So this mapping task is done as per the definition of the client. Client has to define what is to be done, and then this output is created. Now there is one more task called as shuffling task. That shuffling task is done by the framework, Hadoop ka framework. So what this framework will do, that it will shuffle all these keys. Shuffle means it will just transfer keys from one machine to another machine, one machine to another machine. Like this, the keys are shuffled within the framework. So here this key, here there are two keys, K1. Here one key K1, and here there is one key K1. All these K1 keys, so shuffling is done in such a way that the same key will go to same machine. So as per my assumption that here K1 and K2 are brought to this machine. This is a computer reducer where reducer will work. So on this machine, all the locations from of the clusters of the millions of computers and millions of processes or thousands of processes, from all the processes, all K1 and K2 will travel and will come to here to this machine. Okay, so shuffling is done by the framework. So all K1 are residing here. तो यहाँ से दो K1 आ गया. हाँ, one K1 and one K2 from this machine, one K1 from this machine, and one K1 is from machine. And this is shuffled, and it is acting as input to this reducer. Okay, it is stored somewhere here and in the memory, and then it is acting as input to this reducer. So now what are the remaining keys here in this example? K3, K4, and K6. So all three remaining keys will reach here on this machine, and this is the input to this reducer. So it will do this particular shuffling task in such a way that there will be a proper load balancing within this architecture. And now this reducer will start working, and reducer will take this input of these keys and values. Even sometimes the combiner is working here. After mapping, combiner is working here. What this combiner will do is that for suppose there are two keys here. So it will here only it will create that K1 and the values का दोनों values जो है उसका it will create a list of value. See here it is only key and value, but when it is shuffled and it is reaching here, it will be in the form of a key and list of value. So it will here only the combiner can combine this K1. So only one signal will be there. Otherwise, it has to. This machine has to send the first K1 and then second K1. So the traffic is more. To reduce the traffic or to have the efficiency, it will send only one signal K1 with the list of values 1, 1. Like this also, this is the job of combiner. If it is combiner operation is written by the user, but then the user will have to write a combiner here. But it is optional. Okay, so here I'm showing here in this example that the combiner is there and combiner has combined these two values, and the list of values are acting as an input to this reducer. Now this reducer will work on this input, and then it will generate the final output. Okay, so now the final output is always in the form of part 0. The first chunk of your output is part 0, named as part 0. The second chunk is named as part 1. The third chunk is named as part 2. Like this it will be numbered, and this will be the name of the output file. You need to specify your input file name and output file name in your program in the main application. So user is specifying the name of the output file as output.txt. But when the output is stored, if the output is too big, then output is also distributed. If output is not big, then maybe it is residing on only one machine with one reducer. But if output is big, it is also available in the form of a distributed file. And the names of the files are given in such a way that it is dash part 0, dash part 1, dash part 2, and output is the name which is provided by the client, output.txt. In my program, I'll say that my input file is feedback.txt and my output is output.txt file. And then once the output is ready, client can initiate the operation of reading output.txt to read the output. Okay, so this way this mapping and reducing mapper and reducer is working. So this is a map reduce component. Okay, that is the third component of your Hadoop framework. And this is I'm talking about Hadoop 2.0 is the current version. Okay, so but in the exam you need to write down in the form of English statements like this. So once you remember the diagram, you can write it. That MapReduce is a software framework for writing application. It provides APIs, parallel processing is possible. 3 tasks are there: mapping, shuffling, reducing. So I've created a diagram so that it's very easy now to write the answer for this question. Okay, so you will be able to do that. And then there will be a single master job tracker, but there are many task trackers. The task trackers are slave, and then if the task is failed, then job tracker can reinitiate the task on the other machine. So mapping may it will take the input in the form of a key value. So in the previous example, what will be the input to the mapper is the name of the file, and the value is the block. Okay, so this will be the input to the mapper task. Then shuffling is done by the framework. Reducing is normally a combination or aggregation kind of function. Okay, addition or subtraction or average or maximum or minimum, such kind of operation is done in the reducer. So reducer is not mainly, it is not a very heavy job. Mapper is your heavy program or algorithm. Main logic is in most of the time is in the mapper, but reducer just does the aggregation, maximum finding, average, sum. something like light job. Okay, and then with respect to the processes, job tracker and task tracker. So MapReduce में क्या लिखना है तुम्हें? Programmer is going to write these three tasks: mapper task, reducer task, and the shuffling task by framework. And it is given entire job is submitted to the job tracker, and the tasks are executed by the task tracker. This is from the programmer point of view. But from the cluster point of view, in the cluster, these three processes are there: job tracker, task tracker, and job history server. Job tracker is the initial version of Hadoop. Job tracker used to do a job of resource management also, but now that is done by Yarn. So we say that it is monitoring the job, whether the job is to be executed, all the tasks it monitors, re-executes the failed task. Then task tracker performs the actual task as per the directions given by the master. And then in case of failure of job tracker, there is a job history server. So backup of everything is there in the job history server, and you can recover the information which is there onto the job tracker if the job tracker is failed. Okay, because we have to handle the failures. Failure handling is a major task in Hadoop clusters or big data. If sometimes they ask only for 5 marks, then high level architecture of Hadoop. If it is a high level architecture of Hadoop, many paper setter or a paper checker examiners, they expect this particular diagram. Okay, so I have just going through the diagram again. This is a high level architecture of Hadoop. Here divided into two portions: HDFS layer at the bottom, MapReduce layer at the top. And the HDFS layer, this is the name node, and these are the name data nodes running on multiple machines. Even one data node can be running in the same server. It is also allowed. But in real clusters, it will not happen. Okay, big clusters. And then MapReduce layer may the job tracker and task tracker are the component. All the task trackers are running at the slave nodes. So same diagram is represented in the different manner in the high level architecture of Hadoop. And what they say that write down about name node and data node. Name node coordinates and monitors the data storage functions. Client communicates with the name node always to get the data nodes to store the file. And the blocks are read sequentially. Sequential access is there. It is not a random access. And then client machine loads the data and MapReduce into the cluster. So the program part, mapper and reducer is received by task tracker, data file is received by the data name node, data is stored, and then the tasks are executed. So job tracker का function है coordinates the parallel processing of data, and if the reduce task is executed on separate data node, then intermediate results are sent over the network for final computation. Okay, so this way I have explained this. So this diagram is for high level architecture of Hadoop. Okay, now the last component is Yarn. In Hadoop 1.0, Yarn was working with along with the job track. Job tracker was Yarn. The job of Yarn is a yet another resource negotiator which performs these two main tasks: resource management of the cluster. See, now you can visualize the entire cluster in front of you. Okay, so the cluster is like many machines, racks, and 64 machines in one rack, and all the racks connected, a huge rooms where so many computers, millions of computers connected to each other, and they are always on. Okay, so the resource management is a major function. How the resource means resource management is a major function of any operating system where you have the resources such as CPU, input output, devices, memory management, CPU management, device management. So how much memory is to be allocated, how many CPUs are allocated, how much time of the CPU is utilized, and what is the priority. All these things are resource management things are done by Yarn. Okay, and in 1.0, job tracker used to do that. Even the job scheduling and monitoring. So it is like a operating system में जैसे job scheduling होता है. So if multiple jobs are there in the running condition, then which job is to be executed and monitor the execution, whether it is over, how much is done. All these things are done by Yarn. So Yarn is running in between MapReduce and HDFS. It is performing and all other components. It is performing resource management. Okay, so it will do the job in such a way that it will optimize the cluster utilization, entire cluster utilization, because the definition like, is similar to the operating system. Operating system का definition क्या है? Operating system is a resource manager of your machine. And what is the job of a manager? To utilize all the resources efficiently. Even that is applicable in the office. In the office, a project manager has given allocated the resources. A project manager ke paas all the programmers and analysts are there. And now it is a manager's duty to identify who is good in what and divide the work and get the work done in less amount of time and good work. So similar to that, the entire cluster is visible in front of Yarn, and Yarn is the manager of all the resources. It will keep track of all the resource utilization, and it will check that everything should happen properly, and everyone should get the access to any resource, and the job should get done in less amount of time. And Hadoop 2.0 is compatible with 1.0. So whatever was working with 1.0, if you migrate to 2.0, it will work. So here in case of 1.0, job tracker was doing all these things, and but the limitation was number of machines in the cluster, and but sometimes it was not that efficiently working. So scalability issues were there. So they came up with the next version, new component called as Yarn, and Yarn is doing all these things where uh, because of the invention of Yarn, again that is the reason that Hadoop became popular with because of the invention of yarn. Now what is allowed or what is possible is to store your graph data. So if you are having a social media kind of website where you have millions of nodes representing people and their connections, and then your data is in the form of a graph, and then such kind of graph processing algorithms or programs execution is possible because of the good resource management of yarn. Okay, so all these three things are possible. Even interactive processing is possible because of yarn. Interactive processing means that here in case of HDFS, if you assume only HDFS, sequential processing is there. So and batch processing, matlab you submit the job and you wait, and then you will get the results whenever the job is executed. By that time, you just have to sit quiet. Okay, so you cannot interact with the system. You just have to submit the job and wait for some amount of time, and then afterwards you see the results in the output file. You cannot interact with the system in HDFS. So that interaction was possible, or interactive kind of processing is possible because of yarn. And because of that only, Hadoop ecosystem ka many components are possible, like Pig is there, Hive is there, PySpark is there. I have seen the Excel that is shared by you people, and everyone has written down PySpark. But why everyone is doing PySpark? PySpark we are going to use with the programs. For 10 programs, we are going to do the programs in PySpark. For project, don't use PySpark. Learn something new, that is Hive or Pig, or something uh, new language. Okay, so such kind of Pig or Hive or data warehousing is possible because interactive processing is possible, and that is because of yarn only. Even stream processing, matlab your IoT kind of devices are there, and I'm just going to take 5 or 10 minutes more. Okay, so that I'll finish this. Stream processing means you have a sensors, IoT devices, and continuous information and signals are there, and such kind of huge data ka processing is also possible because of yarn. Okay, so it performs even batch processing also, as well as this interactive processing, graph processing, stream processing is done very well because of the good management of yarn. So that's what I'm just telling. Spark, Hive, HBase, NoSQL is allowed, or is working of these tools is possible because of the invention of yarn. So what is yarn? Whenever you are saying yarn, always remember you need to write down the information about three components of yarn. The major component of yarn is the global resource manager. Here it is a global resource manager. See, these are the clients. Multiple clients may communicate with the cluster at a time, and multiple applications can be running inside the cluster. This part of my diagram is the cluster, and these are the clients. Clients will communicate with the cluster. So client will first communicate with the master process of yarn, that is the global resource manager. So the first component of yarn is global resource manager. Second component is this red color, application master. And the third component is this purple color, node manager. Okay, so remember yarn ka matlab always global resource manager, application manager and node manager. Okay, so now whenever the client is communicating with the cluster, it will communicate with the global resource manager. Global resource manager is responsible for allocating the resources and scheduling of the job. So it will identify ये client का एक application है, ये client का एक application है. So for every application, it will initiate a application master. So the application masters are initiated on any one of the nodes or multiple nodes of that particular application where that application's data is residing. Okay. Now here node manager is there on each and every machine. Assume that this particular block is a name is a data node. Okay. This can be a data node machine where data is residing and mapper and reducer will execute on the same machine. For entire application you may have only one application master or more than one application master, but no need of having n number of application master. You can have application master can be distributed. Okay, so you per application you need to have at least one application master or few application masters, but every data node will have a node manager. Data is residing on this node manager. So every data node will have data node of HDFS component. Every data node will have node manager. Okay, so whenever you are writing about yet another yarn, you need to write down about global resource manager, node manager, and application master. Global resource manager का only one copy for the entire cluster. ओके, सो पूरा जो क्लस्टर है मिलियंस ऑफ कंप्यूटर्स पूरा सब क्लस्टर है उसका रिसोर्स ग्लोबल रिसोर्स मैनेजमेंट इज done by this global resource manager component. So it keeps track of the entire cluster कि ये cluster में millions thousand machines है, 1500 CPUs है, कितना hard disk है, कितना memory है, and how much memory is utilized, how much memory is free. So all the global पूरा entire cluster का statistics and availability of resources is there with the global resource manager. Every data node has a node manager because every machine का जो resource allocation है उसका this node manager will keep track of the information of the CPU utilization, memory utilization, hard disk, and all this resource management of that particular machine के लिए this is node manager. So what global manager का task तो वैसे easy है, it will get the data from all the node managers. So that's why ये hard line है, मतलब dotted line नहीं है. All the node managers are always telling about their resource allocated and utilization to this resource manager. So finally, it will gather the information from all the data nodes and it will have the information about the entire cluster. Okay. Then per application, whenever the application is to be initiated, this application master is the ad hoc component. It is not a permanent component. It is an ad hoc component. When the application is to be started, that time the application master is initiated by the resource manager here, and the application master will come into the life. उसका life create हो जाएगा, and it will start running. When the application is to be running, you have to run the application. Application master will become alive, and it will start running. Now, application master will register itself with the resource manager. So both of them they register with each other and they know about each other. Okay. Then application master will negotiate with this resource manager, and it will say that okay, my application, I want two CPUs, I want so much of memory, so much of hard disk, I need this. So they do the bargaining and all this, and all the resources will be allocated and granted by the resource manager to the application master. Then application master will inform that to the node manager. So node manager will come to know, okay, I wanted two CPUs, but I got one CPU. I have to do the job with the by using only one CPU. Okay, I'll do that, and then it will know and that it has need that this much of memory, and then it will utilize that memory and it will start the container because it is a Java-based applications. So you know if you have worked with JSP or other kind of high-level programs that your program is running inside a container. Like even your normal Java program is running inside JVM. So like this, it will then initiate the container and your application starts running inside the container. Okay, so container is shown here in the diagram, but container is not actually a component of yarn. Yarn का components है तीन. resource manager, node manager, and application master. Okay, so this way they work with each other. Okay, so I told you about the working of yarn. You might have got an idea about it, but whenever you're writing the answer, you need to write down in terms of points that global resource manager tracks resources of the entire cluster. It it orchestrates the work by assigning tasks to the node manager. Then the per application there is at least one application master. It will negotiate the resources from the scheduler. It performs the job scheduling is done by resource manager, and it will track the status of the resources of this machine of the entire. So application master will keep track of resources for the entire application. Okay, node manager is with respect to the node, but application master पूरा application के लिए, because application may be running by using 5 6 computers. So it will track the resources for the application. It works with the node manager, and the node manager is responsible for launching application container and execution of the task inside the container. It also monitors the resource usage, how much CPU utilized, RAM utilized, disk where it is stored, network utilization, log management, and it reports to the resource manager. Okay, and there is a configuration file yarn site.xml which will present, which will be there inside the host of the cluster at known location, and some configuration mechanism or something is stored inside this. Configuration related parameters are set inside the yarn site.xml file. Okay, so this is what I told you just now, steps. Now, just 2 minutes, advantages and limitations. Advantages of Hadoop are that parallelly you can execute the systems, fault tolerance is there, high availability is there, scalable, easily machines are added, economical because of commodity hardware, open source, used data can be stored. I'm just skipping, I copied the points of the first slide here again because they are important. Moving computation to the data is allowed, tens of millions of machines, files, reliable authentication, authorization tools available. Okay, so these are the advantages. Limitations are कुछ थोड़ा limitations है because it is directly mounted by operating system. Getting data in and out from the existing operating system is inconvenient because we are in the habit of using our DOS operating system and Linux operating system. And suppose you want to access the file of HDFS, then the format is different and you cannot easily get data from HDFS, and communicating with these two kinds of environments is not that easy. You have to mount HDFS and then get the prompt and then give some commands and then you can see the contents. So it's a little tedious task. It's not as easy, nahi, comfortable nahi hai. But like if you are working as a student, then it is not convenient. But as an administrator with the real cluster, it is not a problem. But as a student for the learning phase, that's why like it is not very easy. As a Python, you just install the Python and start working with Python. It's very easy. वैसा नहीं होता starting में mounting, unmounting, and then understanding the HDFS commands, starting the cluster, and this takes time and tedious task. And if you're not expert in that first procedure only, then you leave it, and then that's why you don't study it properly. Okay, so we need to be expert in this particular field. So that's why the first experiment is installation of Hadoop HDFS. Then the second limitation is that file access can be achieved through
Ma'am,
yeah.
it's already 2 o'clock, and
Yeah, just 2 minutes. Last slide.
okay,
Last
okay,
slide.
okay.
So APIs are there, and you access the file through APIs, okay, or a command line interface. And then security के लिए there is no encryption, so your data is not stored in the encryption formats. That's why government agencies or people who are having their credit card kind of data cannot be stored onto Hadoop. And then it is vulnerable by nature because it is written in Java, and now people are expert in Java. They know in and outs of a JVM, and then the cyber crimes, it's vulnerable to them. They can easily crack. Or it is not very fit for small data. If you're writing any program, it's not fit for small data. So don't go for HDFS. If it is a small data, do the normal analytics. And some stability issues are there with the open source softwares because People keep on adding components, and then other limitations are about um, Google is saying that Hadoop is not only the single solution. Now Google is saying cloud data flow is also one of the solution of Google, or Flume is also there. Okay, so this is covering major syllabus or a few important questions from UT2 point of view, and then so I'll stop for today. So what I'm saying you is that for the mini projects, all of you have written down PySpark. So remove that PySpark and use another tool. You will learn something new. Use Hive or Pig or Flume or some other new language, Kafka. Okay, for the mini projects. So see you tomorrow.
Ma'am, wait.
She left. What happened?
Had to ask her for that question bank.
Okay, I'll ask her.
Yeah, thanks.
I think, ma'am.